Hello, this is Mr. Kingsbury from your Algebra 2 class. We're talking about solving rationals today, and today we are finally getting to the solving part of solving rationals. Yes, we have talked about simplifying rationals using multiplication, using division, using addition, and using subtraction, but now we're going to put all that together and actually solve them. Don't forget to put the period you have me and the date that you're writing this down on your paper. Here is your essential question. How do I solve rational equations? And I got to be honest, I'm really glad you asked. It kind of depends on whether you are adding, subtracting, multiplying, or dividing. And as always, the adding and subtracting is handled a little differently than the multiplying and dividing. Truth be told, you're probably going to find multiplying and dividing a little bit easier. But we're going to do a little bit of both here. We're going to actually do all of them. I've got about 6 examples we're going to do here. We'll do a little more in class. Should be amazing. So let's just jump to it. The first example I'm going to give you is a very simple one. We've got 2 over x plus 3 over x, and that's going to equal 10. Now, the first thing I notice is this is addition. And anytime we are adding fractions or subtracting fractions for that matter, we need a common denominator. Well, we already have that. They're both over x, which is awesome. This means I can rewrite this whole equation over one denominator. And to make my life easy, I was going to do something. I was going to suggest we make it a proportion. So, you know what? Let's do that. Like this, we'll make it 10 over 1. And look, I can add this. 2 plus 3 is 5. So I get 5 over x equals 10 over 1. And how do we solve proportions? That's right. We pray for a miracle and hope God does for it. No, I'm just kidding. What we do is we cross multiply. So we'll multiply here and we'll multiply here. So we got 5 times 1, and that's going to equal 10 times x. 5 times 1 is 5. 10 times x is 10x, and if I divide both sides by 10, I get 1/2 equals x. Isn't that amazing? That was super easy. Now, I got to be honest with you, because I always like to be honest with my students. The adding and subtracting problems could get significantly more difficult. We're going to keep them fairly tame. The whole finding a common denominator thing can get complex. We've removed the factoring bit from it, so you're not going to have to do any other factoring but greatest common factor factoring. And I don't think that you're going to have to worry too much about finding like denominators or common denominators. I mean, you will a little bit, and I have a couple problems coming up like that, but it's not anything horrendous. Plus, once you get things kind of sorted out and simplified, the rest of it is usually pretty easy. Let's look at another one. This time we're going to have 5x plus 3 over 3x. And from that, I will subtract x plus 1 over 6x, and that's going to equal 6. Now, the first thing I notice is it's subtraction. With subtraction, you got to make sure you handle your negative here correctly. We'll get to that in a moment. First, though, we also need a common denominator. Now, I notice the denominators have an x in common. That is outstanding. That means all I have to do is adjust the number. And I happen to notice that 3 is a factor of 6. In fact, I could multiply 3 and 2, and I get 6. And if I multiply the bottom by something, then I got to multiply the top by it. So what I can do then is distribute this 2, and I get 10x plus 6. And then I've got this minus x plus 1. And now I can just put it all over 6x. Because look, 2 times 3x is 6x. And this is just straight up 6x. It still equals 6, by the way. Yeah, that hasn't changed. I want to kind of focus on this numerator for a second and make sure I handle it properly. So I'm going to rewrite it. I've got 10x plus 6 minus x. And don't forget, you are subtracting the 1 as well. Usually, the big mistake people make when working these kinds of problems is they apply the minus to this first term, but they forget to apply the minus to the second term. Everything in these parentheses is being subtracted. That needs to be reflected up here, but without parentheses, so that I can then combine my like terms. 10x minus x is 9x, and 6 minus 1 is 5. So I got 9x plus 5 over 6x is going to equal 6. And once again, I'm going to make it a proportion. And I'm going to cross multiply. And forgive me, I ran out of room a little bit. So I'm going to work it over here, off to the side just a little. I've got 1 times 9x plus 5. And that will equal 6 times 6x. So I'm going to distribute. 1 times 9x is 9x. 1 times 5 is 5. And 6 times 6x is 36x. So I end up with 9x plus 5 equals 36x. And I'm going to subtract 9x from both sides. I get 5 equals whatever 36 minus 9 is. Pretty sure it's 27. And then I'll divide both sides by 27. Now this is not pretty at all. It's a disgusting decimal. So rather than write out the decimal and round it and lose accuracy, I'm just going to leave this as 5/27, which does not in any way reduce. And there we go. So that's an addition problem and a subtraction problem. Next up, I want to do a multiplication problem for you. And again, I think you're going to like the multiplication and the division, because they end up being a lot easier, truthfully. So here we go. We've got x minus 3 times 2x plus 18, and that is over, I need to do better with my handwriting. 2x plus 18. And that's going to be over x plus 3 times x plus 9. And we're going to take that and multiply it by the following. X plus 3 times x plus 4. And that will be over x plus 4 times 2x minus 6. And all of that will be equal x plus 5. Now, if you recall, when we simplified rational expressions using multiplication, the first thing we had to do was factor. So we need to factor some stuff here. Now, really the only factoring you guys are going to need to worry about is greatest common factoring. So we're going to look and see if there's anything that's common to both terms in each parentheses. There's nothing here or here or here, but look, 2x and 18 are both divisible by 2. And if I factor that out, I'm left with x plus 9. 18 divided by 2 is 9. So there's that. Nothing to factor here, nothing to factor here, nothing to factor here. This is also factorable by 2. And when I factor 2 out, I get x minus 3. 6 divided by 2 is 3. So I end up with this. The next move then is to cancel anything that I can. As long as the factor is on top and on bottom, it cancels, which works out really quite nicely. So let's see what we can cancel. I see the x plus 9 is going on here. I see x plus 4 here. X plus 3, x minus 3, the 2's. In fact, every single thing cancels. And when that happens, that means the whole thing is equal to 1, which leaves me with this very simple problem. 1 equals x plus 5. And if I subtract 5 from both sides, I get negative 4 equals x. Isn't that awesome? I figured you guys would like that. Let's take a look at a division problem now. So we're going to have 2x plus 5 times x minus 3 over x plus 3 times x minus 3. And we will be dividing that by 4x plus 10 times x plus 2 all over x times 10x, times x times 10x plus 30 is what I should have put there. And all of that will equal 1. And I've kind of given away a little bit of the surprise here, but that's okay. So the first thing you have to do when dealing with division is you have to rewrite the problem. You can't divide two fractions straight up. It just doesn't work. What you have to do is multiply by the reciprocal. So we will keep the first fraction exactly the way that it is. That will not change. What we're going to do, though, what we will change is division into multiplication. And we're going to flip this second equation, or this second fraction, excuse me. We're going to put x and 10x plus 30 on top. And on the bottom, we will put 4x plus 10. I can factor out a 10. And when I do, what's left is x plus 3. And on the bottom, I can factor out a 2. And what's left is 2x plus 5. And then from here, I cancel. So 2x plus 5, that's going to cancel. X minus 3 is going to cancel. X plus 3 is going to cancel. Wow. That's pretty awesome, really, truthfully. The other thing I noticed, all these other things cancel, but there's an x on top and there's a 10. And there's a 2 on bottom and x plus 2. All right? And I mean, I could write that out for you. If I do, it would be 10x over 2 times x plus 2. 10 divided by 2 is just 5, or 5. I've got this fractional thing going on. It's a proportion. I went ahead and made 1 into a fraction by putting it over 1, and now I can multiply. So I got 1 times 5x. 1 times 5x, and that will equal 1 times x plus 2. And of course, when I distribute, I get 5x equals x plus 2. I will subtract x from both sides, so 4x equals 2. Divide both sides by 4, and x is going to equal 1/2 or 0.5. Either way, it is absolutely fine. So there's that. Over 3x will equal 2. And because it's addition, which is what I see right here, I'm going to need a common denominator. Now, I already have an x in common. I just need to find a number that 5 and 3 have in common. Well, that would be 15. In order to get 15 over here, I would multiply 5 by 3. So I'm going to multiply this by 3. And whenever I multiply the bottom by, I multiply the top by. Similarly, I would multiply this by 5 to get 15x. So I'll multiply the top by 5 as well. When I distribute, I get 3x plus 3 over 15x plus 5x over 15x, and that's going to equal 2. And now that I have a common denominator, I can rewrite everything over one denominator. So 3x plus 3 plus 5x over 15x will equal 2. And I ran out of room, so I'm going to scoot over just a little bit. And then I can combine like terms in the numerator. So 3x and 5x is 8x plus 3 over 15x is going to equal 2. And once again, I'm going to make this a proportion and cross multiply. So I've got 2 times 15x and 1 times 8x plus 3. I distribute and I get 30x equals 8x plus 3. And if I subtract 8x from both sides, I get 22x equals 3. And I'll divide both sides by 22. And I can promise you that that is not a fabulous number at all. So I'm going to leave it as 3 over 22. Hope you can see that. There we go. That's crazy. Very crazy. Last one. Last example. Love it. This last one is going to be division. Do I want to do that? Maybe that's enough. Yeah, I think we're good. We'll call it there. All right, so that last one was the last example. Thanks for playing along, and I will see you in class.